What's the most expensive thing you can actually picture in your head? A mansion, maybe. Private jet. Some absurd diamond necklace behind bulletproof glass in a jewelry store window. Now forget all of that because none of it comes close. Roughly 40 light years from here, there's an entire planet that scientists genuinely believe is made largely out of crystallized carbon. In other words, there's a planet out there that might just be, more or less, one giant diamond twice the size of Earth. Hey, I'm Potato, and welcome back to another trip through the universe's weirdest corners. Today we're talking about 55 Cancri E, a real planet with a real, semi-serious nickname among astronomers, the Diamond Planet, and honestly, once you hear what it's actually made of, you'll understand why. If you're the type who enjoys finding out the universe is stranger than fiction, subscribing means you won't miss the next one of these. Alright, let's actually get into this ridiculous planet. First, some basics. 55 Cancri E orbits a star in the constellation Cancer, close enough to Earth in cosmic terms that astronomers have been able to study it in surprising detail using telescopes and specialized instruments designed to analyze the light passing through and around distant planets. It's classified as a super-Earth, meaning it's rocky like our planet but noticeably larger, roughly twice Earth's diameter and about 8 times its mass. So already, before we even get to the diamond part, we're talking about a genuinely massive rocky world. Here's where things get strange, though. 55 Cancri E orbits its star at an almost absurdly close distance, completing a full orbit in less than 18 hours. For comparison, Earth takes an entire year to circle the Sun once. This planet does it in less time than it takes you to sleep and go to work the next day, repeatedly, forever. Being that close to its star means the planet is scorching hot, with surface temperatures estimated to reach somewhere around 2000 degrees Celsius. Hot enough to melt most metals we're familiar with here on Earth. Now, here's the part that gets genuinely fascinating. Based on measurements of the planet's mass and size, combined with what scientists understand about the chemical makeup of its host star system, researchers proposed a theory suggesting that 55 Cancri E might have formed from a very different mix of raw materials than Earth did. Our planet formed primarily from oxygen-rich material, which is why Earth's interior and surface are dominated by rock, silicates, and metal oxides. But the star system containing 55 Cancri E appears to have a significantly higher ratio of carbon compared to oxygen than our own solar system does. That distinction matters enormously, because when a planet forms from a carbon-rich environment instead of an oxygen-rich one, the chemistry that builds it changes dramatically. Instead of forming familiar oxygen-based rock and silicate minerals like Earth's crust and mantle, a carbon-rich planet could theoretically form significant amounts of graphite, and under enough pressure and heat, carbon can crystallize into an entirely different structure, the same structure that makes up diamonds. Deep inside 55 Cancri E, the pressure would be absolutely immense, far beyond anything found inside Earth, simply because the planet is so much larger and denser. Under pressure and temperature conditions like that, if there really is a substantial amount of carbon down there, some scientists have proposed that a meaningful portion of the planet's interior could exist as crystallized carbon, essentially enormous formations of diamond, layered throughout parts of the planet's structure, rather than existing as a small vein or pocket the way diamonds form here on Earth. To be clear, this remains a genuinely debated area of active scientific research, not a settled, universally agreed upon fact. Other researchers have proposed alternative models suggesting the planet's carbon-to-oxygen ratio might not be quite as extreme as originally calculated, or that the interior composition could involve other exotic materials entirely, given how difficult it is to directly observe what's happening inside a planet 40 light-years away. Scientists continue refining their models as better data comes in from more advanced telescopes and instruments. But the core idea, that this particular corner of the universe might have built a planet out of fundamentally different raw ingredients than our own solar system used, remains a genuinely compelling and scientifically grounded possibility. Here's a fun way to think about why this matters beyond just being a wild headline. Planet formation isn't a one-size-fits-all process happening the exact same way in every star system across the galaxy. Different stars form from different clouds of gas and dust, containing different ratios of elements depending on what happened in that particular region of space before the star system even existed, things like nearby supernova explosions seeding the area with specific elements, or the composition of the original nebula the star condensed from. Change those starting ingredients even slightly, and you can end up with entirely different categories of planets, worlds built from fundamentally different chemistry than anything in our own cosmic neighborhood. our solar system, with its oxygen-rich rocky planets and gas giants, is really just one particular outcome from one particular starting recipe. Nothing about the universe requires planets to be built the way Earth was built. 55 Cancri E, whether or not the diamond interior theory turns out to be exactly correct in every detail, is a genuine reminder that planetary chemistry across the galaxy could be wildly more diverse than anything we'd naturally assume based on our own limited sample size of 8 planets. And there's something almost poetic about it too. Diamonds, here on Earth, are treated as one of the rarest, most precious substances humans can get their hands on, carefully mined, cut, polished, and locked behind glass because of how scarce and difficult they are to find in meaningful quantities. But scale up the perspective far enough, go far enough beyond our own solar system, and you find a place where that same material might not be rare or precious at all. It might just be what the ground is made of, an entire world where the stuff we treat as priceless jewelry could, in theory, just be bedrock. So, that's 55 Cancri E, a scorching hot super-Earth, orbiting dangerously close to its star, potentially hiding an interior built from crystallized carbon on a scale that makes every diamond ever mined on Earth look like a rounding error. Whether the full diamond planet theory holds up exactly as originally proposed or gets refined as we learn more, it's a genuinely great example of how different the universe can look once you stop assuming everything out there has to resemble home. That wraps up this trip through the diamond planet. If your brain enjoyed that little detour into cosmic chemistry, there's plenty more strange planetary stuff where that came from, so don't wander too far. Catch you in the next one.